Good morning, everybody. Today we're going to be working on function notation, which is actually incorporating skills that you already have and moving forward into a different way of presenting them or writing them. So I apologize in advance for the crude writing on this. It's not particularly helpful. So what I was referring to in the skills that you already have is you know how, in this warm-up, you know how to solve or find y when x equals 5. So you've got y equals 5 minus 4 times 5 plus 6. And then you just need to evaluate. So 5 minus 4 is 1, 5 plus 6 is 11, and 1 times 11 is 11. Alternatively, when I know what y is, again, I plug that in for y, and then 2 times x minus 4 plus 8. There's a couple ways I can go about this one. I'll go ahead and distribute. So 2x minus 8, and then drop down everything I haven't used. So the plus 8 and the equals 10. Then I'm going to combine like terms. Negative 8 and positive 8 give us 0, so those add out to 0. So I'm left with 2x equals 10. I divide by 2 and get x equals 5. So you're going to be using that skill today with function notation. You're just not going to be writing it exactly the same way. So a function is an equation or graph in which there's, for any value you input, there's only one output. So what I mean by that, when I look at a function, I have to determine if there's only one x value, or sorry, excuse me, there's only one y value per x value. When we're looking at a graph, that means it has to pass the vertical line test. So if I draw any line, a vertical line anywhere on this graph, it's only going to pass through that little curve one single time. So this first one is a function. So yes, that is a function. The second one, if I put a vertical line anywhere on here, it's going to pass through twice. And so that one is not a function. The third one, this kind of looks like a sideways parabola here. That is also not a function because my vertical lines are passing through twice. And my last one here, vertical lines crossing, this one is a function because it doesn't pass through that graph more than once. And it's only a vertical line, not a horizontal line, just an FYI on that. So, function notation, the equation is y equals 2x minus 3. The function notation is simply f of x equals 2x minus 3. So the only difference here is instead of y, we're writing f of x. The way that we read this is f of x. F is not a variable. It doesn't mean we're multiplying f and x. It's just a way of naming our equation. So it's essentially the same thing as y, and we can use them interchangeably. So when we refer to the name of the function here, most of the time it's f. However, if we have multiple equations and we want to refer to them separately, we might have f of x and g of x and h of x, so on and so forth. Whatever is inside these parentheses, that's our input, and whatever comes out is our output. So as we move forward, we're looking at this in terms of the warm-up. So we had find y when x equals 5, and then we had our equation. If we have f of x equals x minus 4 times x minus 6, and we want to find f of 5, the way we would write that is f of 5 equals, and whatever is in place of x here, I'm going to put in place of x here and here. So it's going to be 5 minus 4 times 5 plus 6, which we did in the warm-up. So our answer here would be f of 5 that same side doesn't change, just like it would be if it were y, equals 11. Same thing here, except now when we have f of x equals 10, we're plugging in this 10 for that f of x. So we do it the same way. So 10 equals 2 times x minus 4 plus 8. And again, we solve. So we're going to end up with that, I think it was x equals 5 from our warm-up. So same process, just different way of writing it. Determining whether the following could be a function. The first graph contains the point 2, 3, 5, 3, 6, 4, and 6, 8. This one is not a function, and the reason is that we have two x's that are 6 and two different outputs that are different numbers, and we can't have that. On the next one, a graph containing the points 2, 3, 3, 3, 4, 3, and 5, 3. For any individual x value, we only have one y value. So the y value can be the same. Incidentally, this would probably look like a straight horizontal line, and that is a function. Graph containing 5, 8, 5, 9, 5, 10, and 5, 11. That is 4 different y values for the same x value. That would most likely look like a vertical line, and that is not a function. Finally, the last one, 1, 1, 2, 2, 3, 3, and 4, 4. That can be a function because we only have one y value per x value. On the following, this is passing the vertical line test, so yes. Not passing the vertical line test, that is no. And this one is a vertical line, many, many values there. So it's crossing through many times, infinite number of times, in fact. So that is not a function as well. Evaluating for a given variable. When we know what that x is going to be, we just substitute it in. So f of 4 equals 5 times 4, and we just evaluate. We just do the math from there. So f of 4 equals 20. F of negative 3, sorry for the messy writing. We just substitute it in. If the negative 3 is here, then we put it in here. So 6 parentheses negative 3, I don't know why my 3's are coming out so funky, plus 5 equals negative 18 plus 5 equals negative 13. And the last one, f of 2 equals 2 times 2 squared plus 3 times 2 minus 5. So if there are multiple x's in the equation, you plug that same number in for all of those x's. So in the order of operations, 2 squared gives us 4, so I have 2 times 4, 4, sorry, plus 3 times 2 minus 5. So I'm going to bring that over to the side here. 2 times 4 gives me 8, plus 6 minus 5 gives me 14 minus 5, which is 9. So when I know the x, when there's a value in place of the x, then all I got to do is plug it in and do the math. On the other hand, when I know f of x equals something, then that's when I have to solve. So here f of x equals 30, so that 30 goes in for that f of x. So 30 equals 5x. Divide by 5, so x equals 6. So when I'm evaluating, I'm going to end up with a number. When I'm solving, I'm going to end up with x equals a number. 65 goes in for that f of x, so 65 equals 6x plus 5. Subtract 5. 60 equals 6x divided by 6. So x equals 10. And on the last one, 0 equals 2x squared, minus 1x minus 6. That 0 is going in for that f of x. On this one, I can, it's a quadratic with both an x and an x squared, so I have to either use the quadratic formula to solve, or which will work every time, or the factoring and zero product property to solve. I don't have the space to do that, and it would get very, very messy. So I'm going to go ahead and conclude this lesson on the function notation. If you need further instruction on the quadratic formula or factoring and using zero product property to solve, then I would go back to those sections, those videos. All right, that is it for function notation. There's a worksheet as well, so when we get to that, or if you get that from me, then that can give you some extra practice with this. Have a good day.